hello guys. For my content, we do for cover 3 point, which is operation of 3-phase induction motor, reversing the rotor rotation and speed control. Okay, definition. Asynchronous motor is a machine whose rotor rotates at the speed less than the synchronous speed. Okay, then for operation I will explain later. And this type of motor, AC induction motor, is known as the asynchronous motor. Follow the name of type of motor. They have a slip. The value of slip is not equal to 0. Different than synchronous motor. Okay, for additional power source, asynchronous motor does not have DC motor like synchronous motor. So they can start self-starting. Okay, for the slip ring and brushes are not required for asynchronous motor. The cost is cheap because the component using is decreased or minimum. Okay, for efficiency, the asynchronous motor is less efficient than synchronous. So for the power factor, asynchronous motor run only at lagging power factor. And speed, for the speed of the asynchronous motor decrease with the increased load or more load at the synchronous motor, they will decrease the torque of the motor. Also the speed. For operational speed, the above 600 rpm speed motor operation is excellent, while synchronous motor operates smooth and good below 300 rotate per minute. 3-phase induction motor is contain 3 set coil because we use 3 phase. So when we apply AC voltage to coil, it produce a magnetic field which change in intensity as well as polarity. So connect each coil to a different phase. Electron each phase will change direction forward and backward at different time compared to other phase. Means change intensity and polarity at the different time compared to other phase to distribute this magnetic field. Okay, which we can apply the Faraday law. When the rotor is stand still, the flux of rotating magnetic field cut every solid conductor of the rotor. As the rotor conductor are stationary and sinusoidal, stator field is rotating, there will be a change in flux linkage. With the rotor conductor as a result, there will be an induced current in the rotor conductor as per Faraday's law of electromagnetic induction. Whenever this current starts flowing through the conductor, it reacts with the every unit field carrying conductor inside a magnetic field experience a mechanical force. Okay, then the rotor need to rotate the coil. We need to rotate the coil 100 degree from the last phase and combine this into motor stator to produce magnetic field. Rotating magnetic field will cause the rotor which sit inside the coil to spin. Okay, reversing the rotor rotation. For the induction motor, the reversing method is when the motor stator is quickly reconnected for reverse rotation by switching 2 of the 3 input voltage line. It will quickly build up a reverse magnetic field that will begin to rotate in the opposite direction. So we can see the following example, which the motor which will rotate clockwise and B will rotate counterclockwise by incoming voltage line swap. As you can see, L1, L2 in the left and the right. Okay, lastly the speed control. Okay, as we can see, formula that the speed of three-phase induction motor can be changed by means of changing the number of induction motor poles, the slip and the frequency of the power supply. So we can use this formula to manipulate the speed of induction motor.
Alright, for my part, I will discuss about torque control, application of motors, fault type and maintenance. Alright, for torque, torque is directly proportional to voltage and frequency. Voltage and frequency is kept constant for maintaining constant torque in induction motor. Thus, using VF control, good range of speed adjustment is achieved in a simple and cost-effective way. Next, three-phase induction motor can be seen used in a lift, hoist, driving, lathe machine. Alright, what is the advantage of three-phase induction motor? Let's see. Firstly, it is low cost. Second is low maintenance cost. Third is easy to operate. Fourth is having a speed variation. Fifth is having a high starting torque. And lastly, it is durability. Alright, in three-phase induction motor, there are three types of faults. The first one is electrical faults, second is mechanical faults, and lastly is environmental faults. Okay, from the electrical faults alone, it is divided into 7 parts. Let's talk about the first one, single-phasing fault. Single-phase fault is occur when any one phase of supply voltage is getting lost because three phases voltage supply is must required for normal working of three-phase induction motor. Due to this fault, the motor could be burned or heat up. Okay, the second one is reverse phase sequencing fault. The reverse phase sequencing fault is occurred when any one of three phase voltage supply is reversed, means the phase order of supply voltage are swapped. Due to this fault, the direction of rotation of motor has changed. Okay, the third one is under or over supply voltage fault. Under or over supply voltage fault is occurred when supply voltages are under or over the specific limit. The limit of three-phase AC supply voltages is 380 to 440. So, when supply voltages are across this limit, the motor could be burned or heat up. Okay, the fourth one is overload fault. Overload fault is occurred when motor is overloaded, means the higher load is connected at output side of motor, and due to this load motor could be heat up or excessive vibration. Okay, the fifth one is earth fault. Earth fault is occurred when any one phase supply voltages is connected to the housing of the motor, then the motor is totally shorted. In this condition, when anyone touches this motor, then he will feel the heavy shock. The motor would take over current that could be dangerous for induction motor. Okay, the sixth one is interturn short circuit fault. Interturn short circuit fault is the such type of fault when two turns of same phase or different phases are short circuited. During this fault, the motor could be totally damaged, or coil of that specific phase could be damaged. Okay, the seventh one is crawling fault. Crawling fault is basically an electromechanical fault in three-phase induction motor. This fault is occurred when motor is fully loaded with full supply voltages. Then it does accelerate, but it runs nearly 1/7 of its synchronous speed. This specific phenomenon of induction motor is called crawling. Alright, the second type of fault in three-phase induction motor is mechanical faults. Mechanical faults are such type of faults which are generally occurred in internal housing of three-phase induction motor. These faults are further subdivided into three types. The first one is broken rotor bar fault. Second one is rotor mass unbalanced fault. The third one is bearing fault. Alright, the third type of fault in three-phase induction motor is environmental fault, with surrounding environment such as ambient temperature and moisture and others effects on the performance of induction motor. This factor reduces the performance of induction motor. The very first thing that you should do before starting any type of maintenance of a motor is a visual inspection. A lot of times the trouble can be found just by looking, because if the problem is that bad, then it should be very obvious by observation. Listed below are just some of the visual checks that you can perform before disconnecting the motor and taking it apart. An important aspect of large machine maintenance is the visual and mechanical inspection. The first one, inspect the machine's physical and mechanical condition. The second one, check for signs of oil or water leakage. The third one is check for abnormal sounds or smells. The fourth is check the surrounding for any environmental issues that may affect performance or service life. Fifth is check for appropriate lubrication or lubrication system. Sixth is verify the bearing oil level. 7 is look for dirty oil or old oil. It should be replaced or tested. 8 is check for poor alignment. And lastly, make sure that there are no rough bearing due to corrosion or careless handling. Alright, that's all from us. Thanks for watching.